ED205, this is the simplest heap overflow. We've done stack buffer overflows, and we've done format string vulnerabilities. Here's a heap overflow. So this program here has got ED205. So if you run it, it's going to tell you you have to give it a string. So if you give it a string like hello, then it runs, and so it tells you where the data is and where the function pointer is, and says level has not been passed. And if you give it a long string, and you still get level has not been passed, but there will somewhere be a level where it'll crash. So that's a story. Now what we want to do is we're going to look at the source code. So let's look at ed.c. All right. So here you are. It's got some libraries. Then it's got a data structure, and this is the point you have. This is a global data structure that has room for 64-character name and then a pointer to a function. And that's going to go in the heap. We have a winner function and a no winner function. And here's the main function that's going to take a variable from the command line, and it's going to allocate that structure, data, and here's the structure FP, which is going to be, yep, there they are. It's going to put them both on the heap with malloc, and then it's going to set the FP to point to no winner. Then it's going to put the data first and FP there and copy the name that came from the argument into that name. So as you can see, I have a 64-character string followed by a pointer. So if I put in more than 64 characters, some of that data should end up in the pointer that is used to control the instruction pointer. So if I do what I did before, I run this and I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There, that's more than 64. And now I get a segmentation fault because some of that stuff ended up in the instruction pointer. All right, so I overflowed the heap, so we can look at it in the debugger. We can do gdb minus q ed205. All right, and I can list 31 to 34 to get to the code that's interesting. And this is the code that creates the overflow. This is where it copies the command line argument into the name field that only has room for 64 characters. So I'd like to break after that at line 33 and then run with a short input. Whoops, I ran with no input. Let's run with AAAA. All right, and so here we are. It hits the breakpoint. And now I should be able to find the heap. If I do info proc, whoa, gotta have lowercase. All right, you'll show you the various memory segments, and here's the heap. So the heap starts at this address. I'll just put that in the clipboard. All right, and quit doing this. And now I want to examine the data there. So let's do that with x130x at that location. There. So here's a lot of memory. This part of the heap is all zeros. If I press enter, I'll see more. And here you see the 4 A's I put in, 41, 41, 41, 41. And here you see some pointers, and 804, you see 804 is near where we are. 804, this is actually a pointer to the no winner function. You can verify that by disassembling no winner. And see the no winner function is here, 804, 84F6, and that's this number. So this right here is the heap data structure that we talked about. It's 64 characters, you put in the name, and then a pointer to the function you're going to go to. So you can see what's going to happen. If we have more than 64, some of those characters will go down here, and we'll be controlling the instruction pointer. So that's the story. So now we just can use an attack file like we've done before in Python. I made it already here called h1. So there it is. This is just going to print 90 capital A's. So if I run that, I get 90 capital A's. And if I feed it into the program, $H1, then I get a segmentation fault. So we're in the road. So now let's check out H2. Let's copy H1 to H2, nano H2. And so I know that 64 is going to do it, so I'm going to put in 70, and then the last 20 I'm going to do differently. So I'll put in 70 here, and then put in, yep, a string of 00. There's 20 more characters. And there we are. So that should do it. That should be a non-repeating string out where the overflow is. And so now we debug it again. And we run it, taking the data from H2. And it crashes, and there we are, 35, 35, 36, 36. Now 30 is 0, hex 30 is the ASCII code for 0, 31 is 31. So this is the 5566. The 5566 in that string is what controlled the instruction pointer. So now I can get out of here and copy H2 to H3, nano H3. And so 5566 is where I'm going to put the EIP. So that's what I thought. I'm just going to trim this. Okay. And then oh, I see. This is 1, 2, 3, 4, 5. That's 10 characters. So what I can do is I can just turn this into 80. It's 80 characters before, and the next 4 characters are going to be the instruction pointer. So I'll put 1, 2, 3, 4 there and make sure that works. That should target the EIP precisely. So now if I go into GDB and I run, taking the data from H3, it should crash at 1, 2, 3, 4, and there it is, 1, 2, 3, 4 backwards. So now I've verified that I know how to hit exactly the instruction pointer. So let's disassemble winner. All right, so there's the address I want. So I put that in the clipboard. Get out of here. Copy H3 to H4. By the way, notice you always keep anything that works. That's why you have a whole series of programs, H1, H2, H3, H4. One thing I see a whole lot of students doing is starting from some example and just constantly changing that one example to solve every problem. And this is really bad, because then if you mess up, you don't have any way to go back. You always have to have a series of versions so you can go back if you go down the wrong way. So now I nano H4, and so here I want to put a comment. That's the address I want. So I need to put that in instead of this, which is going to be just putting them in \x CB, \x84, \x04, \x08. And that should do it, although the stupid colors make it very hard to read. Let me get out of here and print it with cat so we can see it. There. So this is 0804 84 CB, 0804 84 CB. So that should run. So if I run ED and I take the data from H4, it should win, and it does. It shows level passed. All right. So it hit the win function. All right. That's what I wanted to show you. That's a very simple buffer overflow. All right. And there are some more examples down here where you exploit remote servers, 32 and 64-bit, in the same way. So let me stop this one, and